Okay. So here we have a rectangle for number 3. And a rectangle basically has two sides, right? A length and a width. So we know that the area of this is 16 inches squared. What do we need to maximize or minimize for this problem? The perimeter, right? So the first thing you want to do is you want to figure out a formula or an equation for the perimeter, right? Okay, so a rectangle has a length and a width, and the perimeter is always 2L plus 2W, yes? Okay, but now you want to write a function in terms of like x or something. So if the area is 16, how did we get the area? What did we do to get that area? Length times, right, base times height, right. So if this is x, and if x and this side are 16, right? So suppose that's x and this is y. X times y are 16, right? So then if that side is x, how much is y? 16 over x, right? So this is 16 over x. Is everybody okay with that? Okay. So now I can write that in my perimeter. So it's 2 times x plus 2 times 16 over x. Okay? That's the perimeter. Now the problem is asking what is the smallest perimeter, all right? So how do you find the minimum of anything? Derivative, set it equal to 0, blah, 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 blah. Okay, so P of x, let me just write it like this. 2x plus 32x to the minus 1. So it's easier to take a derivative. Is that okay? Okay, so P prime of x is, derivative of this is, okay, now the derivative of this, so it's going to be minus 32 x to the minus 2. Is that okay? Okay, now I got to set this equal to 0. Okay, so once you're done taking a derivative, writing it in standard form is easier. So we can say 2 minus 32 over x squared is equal to 0. Okay? So now how do we solve this? Or you can add 32 over, you're right. So we could do 2 equals 32 over x squared. Okay? Multiply by x squared. You can cross multiply. So 2x squared is 32. Divide by 2. So x is technically plus or minus 4. Okay, now let's talk about domain. What does x represent? Physically, what quantity does x represent? The length of one of these sides, all right? So it clearly can't be negative. Can it be 0? No. So it just has to be a number that's positive, right? So the domain is x is greater than 0. So here we say x is 4. Okay, and then you get to that point and you kind of forget what the problem was asking you for, right? Yes. So let's go back to the problem. Okay, number 3. What is the smallest perimeter possible for a rectangle whose area is this, and what are its dimensions? So you want the dimensions and the perimeter. All right. So what are the dimensions? How do you know that? One side is x, which is 4, right? So the dimensions are x comma 16 over x, right? So it's 4 and 16 over 4, which is 4. But what were the units? Are they in inches? Were they? Huh?
How is it a rectangle? Because rectangle is also a square.
That's facts. Yep. So 4 inches by 4 inches. See? That's from geometry. And weren't you guys on Zoom for geometry, or were you?
No, geometry
Oh,
was fresh.
you were.
I love geometry.
Right. So regardless how you felt about geometry, a rectangle is still a square, right? Or a square is a rectangle, right? Okay. Wait, one more time.
A square.
Wait, no, not you. One more time. For one more. Okay, this is one that you box. The dimensions of the rectangle are 4 by 4, and then the perimeter is is 2 times 4 plus 2 times 4, which is 16 inches. That's another thing that you box.
Is it inches or
So perimeter is in inches. Yeah. Okay, and this was right. They are in inches, right? I'm just trying to.
Yeah, it's an inch. Wait, so is
Right.
x equals 4 also boxes an answer?
No,
Okay.
it's this and this.
Okay.
Okay, so that was number 3, right? Okay. So, the next one was 6. Okay, let's go to 6. Where is 6? What is 6? How do you say 6? Shesh? It's like sis. Okay. Okay. This is like, okay, a rectangle has its base on the x-axis and its upper 2 vertices on the parabola 12 minus x squared. This is like this one here, example number 3 in the notes, where you basically have a function and then inside the function you have a rectangle. So it's really important in the beginning, or even like me at this stage, I would draw the diagram for this, right? So it says this is under the function y equals 12 minus x squared. So y equals, what shape is this, by the way? Like, this is a parabola, right? Another way to write this is negative x squared plus 12. Yep. Oh, like this. Okay? Now it says inside of this, you've got a rectangle. Okay, so I didn't draw it quite symmetrically, but this is going to be symmetric. That y-axis is going to be smack in the middle. Every single one of the problems that you're given is going to be an even function, which is symmetric around the y-axis. So the rectangle is split exactly halfway with the y-axis. Half of it is on the left, half of it is on the right. Every single time. Yep.
So on a test, is it going to be like where you give us a problem that's already, like, you draw it?
Either it'll be drawn, or like this one, you all recognize that it's a parabola, and then the other one you should all recognize is the semicircle. Right. This one does say parabola. So what is the okay, so let's find what it is that we want to find the maximum of. What is the largest area the rectangle can have, and what are the dimensions? So we want the largest area. Since we want the largest area, I need to write an equation for the area of a rectangle. Okay. Again, we know from back in the day that the area of a rectangle is base times height. I want a color code, okay? So, area of x then is, okay, this is what I'm saying. Every single time you see one of these, the process is going to be identical, okay? The way in math to measure anything, just like when you start measuring like with a ruler, you always start from 0, not from like 7, right? Or if you're measuring in a cup, you don't like, you always count from 0, right? In math, you always start counting from the origin, because that's how you can like measure things, like a ruler. So we always measure from here out. So that distance, it's at some arbitrary point x. So that distance is always going to be x. Whether it's Tuesday or Friday or you're taking a test or doing homework, that's always going to be x. That means how much is the full base of the rectangle? 2x. That is always going to be the same. So blindly, you could just say a of x is 2x times the height. Now let's talk about the height. The height is this. It's the distance physically, literally the distance from the x-axis up to the graph. By definition, that's the function, that's y. That's always y. So, every single time you've got a curve with a rectangle underneath, the area is always going to be 2xy. There is no variety here because it can't be anything else. The y is what's going to change because you're going to have a different function every time. What's the function in this case? 12 minus x squared. So a of x is 2x 12 minus x squared in parentheses. Okay? So now you have to take a derivative. Okay?
Oh, so you wouldn't.
Right. You have to take a derivative. So now you have to think, what's the best way to take a derivative? This is just one function times another algebraic function. There are no roots or whatever. So guess what? Do you have to do u, v, or can you do it in a different way? You can distribute. Okay? So before you even take a derivative, you can say, okay, this is 24x minus 2x cubed. Okay? Now you take a derivative. Oh, 6x squared. Okay? Now we're going to set that equal to 0. But what can we factor out of this? So we get 4 minus x squared equal to 0. Okay. So 4 minus x squared equals 0. What's x? Plus or minus 2. Okay, now let's talk about domain. What does x physically represent? The length, that, right, half that length, right? So it's basically this. Okay? So x can go from 0 to that point. What's that point?
2.
Is it 2?
We don't know.
How do we know? How can we know?
This is not be possible.
Right, so it's definitely going to be positive, but is positive 2 within the domain or it's not? So okay, what happens at that point? It's the what of that function?
0.
The 0 of that function or the x-intercept of that function. How do you find the zeros of any function?
Make it equal.
Make it equal to 0 and solve. So to find that point, we take the function, make it equal to 0 and solve. You guys know how to do this. You do know how to do this. See, if it's taken out of the problem here, you know how to do it. But when we combine it into another problem, you kind of forget, huh? Yeah, yeah. Yep.
Why is the domain only like half of the?
Because remember how I was saying when you start measuring anything, you always have to start from 0? So you always start from the origin. Right? Yeah.
Isn't the domain like everything it covers?
So the domain is the values that x can be. And where do we start measuring x? From 0. So when you take a square root here, x is plus or minus root 12. And then how much is that? 2 root 3. Huh? This is the domain. So this is 2 root 3 and this is 2 root 3, right? So x can have, so the domain is 0 to 2 root 3. Okay, any questions on that? Yeah.
I mean, I don't know what to ask, but I just don't understand
The domain?
like why that's the difference.
Okay, so the domain is all the possible values for x.
Right.
X is the distance from the origin to the edge of that graph. Okay, so it's gonna go from 0 to the edge of that graph. The edge of the graph is the x-intercept or the 0 of the function.
So you set the function.
So you set the function equal to 0, not the derivative, the function equal to 0.
And then you'll find
But I thought
what
it
that
can't touch the S because then it wouldn't be able to.
Right, that's why we're not closing that, we're leaving it open. So technically a rectangle, like it could have up to like 2 root 3. Like it could be a very narrow rectangle like this, yeah.
Question: why is the 2 root 3 on the other side not negative?
Oh, I forgot.
Oh.
Yeah.
Why do we
the 0 to the towards the positive, like why is not the whole rectangle included?
Because the domain is the values of x only. And how did we initially define x? From 0 and on. So this isn't the domain for the base, it's only for the x variable. Okay? All right, so now we basically determined that this is within our domain. Okay, so now again, we have no idea what the question was asking because it's been so long. So let's go over there. What is the largest area the rectangle can have, and what are the dimensions of the rectangle? All right, so let's do dimensions of the rectangle first. The base was x. I'm sorry, is the base x? How much is the base of the whole rectangle? 2x. So the base is 2 times 2, 4. In this case, we don't have units given. Okay, so what's the height? Height is the y, right? So height is 12 minus x squared. So that's 12 minus 4, 8. Okay, so what do we box? The dimensions are 2 by 8.
12 minus 4 squared.
12 minus 2 squared. 4 squared was the other problem, maybe. Okay, so 2 by 8. Oh, 4 by 8, sorry. Okay, and then we also want the area. So the area now is going to be 4 times 8, 32. So the area is 32, and that is your final answer. What number was this?
6.
Okay. All right, questions?
Isn't area supposed to be something squared?
So in this problem, we're not given units because it's just, because it's just by units of x. Yeah.
I'm sorry, I don't think I understand the dimensions. How do you supposed to find that?
So the dimensions are basically the length of the base and the length of the height.
It's always going to be that?
Right.
For every one.
I mean, if it's a rectangle, it's the base times the height,
Okay.
right? Yeah. It's the lengths of the sides. Okay. Questions? Other questions? Okay, let's do 7. 7 was the next one, right? Okay, let's go back to 7. Yeah. Okay. Now, we've got a rectangle. Okay, so we have to, this is the next type of problem, right? So we've got the function, we've got the box. You're planning to make an open rectangular box from an 8 by 15 piece of cardboard by cutting congruent squares from the corners and folding up the sides. Okay, what are the dimensions of the box? Of the largest volume you can make this way. So since we're maximizing the volume here, I know eventually I need to create a function for the volume. So what is it that we're doing? Okay, so I was asking this morning. Are you guys clear on how it is that this box is being made from this rectangular sheet of paper?
Yeah.
Yes, no?
What do you mean congruent square?
Okay, so this is what you start with. What are the dimensions of this one?
8 by
15 by
15 by 8. So this side is 8 and this side is 15, like this, right? 8 and 15. So now you cut out equal pieces from each of the corners. I swear, of all the times to take my scissors away, who stole them?
Want me to go steal?
All right, so look, you cut out a square from each of the sides here. Okay, so now we cut out 4 squares. Each of these sides is x. So it's x and x. Okay, x and x. Now when I open this, I get something that looks like this. It was originally a length of 8. I cut out 1x from here, 1x from here. Now what remains is 8 minus 2x. From this side, I had, 15. Now I cut out an x and an x. Now I have 15 minus 2x. Now when I fold these up, it's kind of like kindergarten magic, right? This is called a net, And you, when you fold these up, you make a box that looks like this, right?
Wow.
Here we go. So now, the height of this box, is how much?
X.
That's the x that we cut out. How much are the sides? 8 minus 2x, 15 minus 2x, x. So, when I draw this box, okay, it's always going to be it's always going to be one of the sides minus 2x every single time. The other side minus 2x and x. It will never be anything different because you can't physically take a rectangular piece of anything and make a box with a different set of dimensions. So side 1 minus 2x, side 2 minus 2x, x, every single time. You can do it blindly. Okay. So now that we wanted to find volume, it's got to be length times width times height. So every single time, you don't even have to draw the box, right? It's always going to be one side minus 2x, another side minus 2x times x. Okay, let's talk about domain now. Huh? No. It's the side 15 minus 2x. Okay, let's talk about domain. You know how we were cutting out equal pieces? This has dimensions of 8 inches, let's say. So suppose I cut out 2 inches from here, 2 inches from here. Now I've got 4 left, right? Okay, I can cut out 3 inches from here, 3 inches from here. Now I'm here. I can cut out 4 inches from here, 4 inches from here. Past that, I don't have material left over to cut. So the most I can possibly cut is half of the shorter side. Does that make sense?
I just need to see it through and then
Yeah.
Is that what the question was?
Literally take a box, take a piece of paper and just look at it. And if this is a length of 8 and I'm cutting out equal pieces from both sides, the most I can cut is 4 from here, 4 from here. Now when I cut those out, there's nothing left for me to cut.
But how do you still have 4 if you already took out 2x?
No. Suppose I haven't taken anything out.
Okay.
Okay? The most I can cut is 4 from here and
Yeah.
4 from here. Then I have nothing else left.
Yeah.
So if x is how much I can cut out, then half of this is the most x can be. Okay? So the domain.
Can you actually cut it in half?
So up to, that's why we don't include it. So it could be 3.99999, okay? So the domain is always going to be 0 to 4. So it's going to be 0 to half of the smaller side. Every single time, huh?
Isn't the width always the smallest or is that smaller?
Oh, you know what? It's so arbitrary what's length and what's width. It's just that's why we do base and height. Yeah. Okay. So, all right. So that's the domain. Now, before you can take a derivative of this, you have to multiply this function out, which I'm just going to cheat here. It's going to be 4x cubed minus 46x squared plus 120x. Okay?
That's just it multiplied all together?
Yeah. Okay. This is the volume. We want to find, was it the maximum volume? Yeah. Right, why would we make a box with the smallest volume, right? That wouldn't make sense. Okay, to find the maximum of anything, what do you do?
Take derivative.
Right, so 12x squared minus 92x plus
120.
equals 0. And now, what can we factor out of this? A 4? Nothing else, right? So it'll be 4, and then it'll be 3x squared minus, what's 92 divided by 4? 23.
You just do that in your head.
No, I did it before.
Okay, so now you gotta factor this. Set it equal to 0. So it's gonna be like 3x and x. And then you see how it's like minus and plus the signs? That tells you it's always gonna be minus minus. So now you have to pick two numbers that multiply to 30, but then the foiling has to be 23. So it could be 1 and 30, 2 and 15, 5 and 6, which I think 5 and 6 works, right? So if you make 6 and 5 like this, like 18 and 5 is 23, so that works. Okay, so from here, x is 5/3. From here, x is 6. Do both, okay, so those are the critical points. In another problem where it wasn't like a word problem, you would have two critical points. You would put them on a number line, maximum, minimum, blah, blah, blah. Fine. But this is now a physical problem. We've got like a sheet of cardboard or whatever, and we have to be able to make a physical box. So 6 is not in my domain because it can only be from 0 to 4, right? So I can just throw away 6. But the 5/3 will work. Okay.
Quadratic equation.
Huh?
We do the quadratic.
The formula?
Yeah, well, yeah.
Whatever works for you.
I had no idea.
It's like trial and error.
We're gonna calculator?
Quadratic formula will definitely work. This will be a calculator section.
Will or will?
This will. Because then you have to plug all these in. Okay, so again, I already forgot what we needed to make. I'm assuming we needed to figure out the dimensions of the whatever we're cutting out. Well, what are the dimensions of the box of largest volume? And what is its volume? So we need the dimensions of the box, okay? All right, the dimensions of the box are this, and this, okay? So let's do that. Dimensions. Ugh. So one side is x, which means it's 5/3. Another side, it's 8 minus 2x, which means it's 8 minus 2 times 5/3. And you use your calculator for that. So what do you get? No, wait.
She's asking for the individual ones.
8 minus 10/3.
Individual ones, I got a 4.66.
It's 8 minus 10/3, right?
Like it's 5/3. 5/3.
No, but it's 8 minus 2x.
Oh, you're right, yeah.
It's 2x, so it's going to be 32, 22/3. No, 14/3. Okay, so,
Yes, 14/3.
Yeah, we just.
so you see how, okay, it's 8 minus 10/3, right? 8 minus 10/3. Is everybody okay with that? It's 8 minus 10/3?
Yeah.
Yeah? Okay, then, so 8 is 24/3, right? Minus 10/3, that's 14/3.
So if
Or if you plug it in your calculator, then you would get like whatever 14, or what did you get?
well, I got a decimal. Well, I think I got 14/3, but I got
4.6,
4.67.
yeah, okay. I'm trying to compare what the answers in the book, and those are in, whatever, so.
Actually, I have the parking lot crumbling down on our bars.
Okay, 50, maybe we can find the rate. What's the maximum amount of volume? Okay, 15 minus 2x is 8 minus 10, I'm sorry, 15 minus 10/3.
11.67.
Yes, it's 35/3. Okay, so what are you gonna box? One is the dimensions, so it's gonna be 5/3 inches. This one you're given inches in the problem.
You don't prefer in like whole numbers.
Huh?
Does it matter?
Decimals or in
Like in fractions, like because it's like a like a length.
One sec, sorry. So it doesn't matter Whether you do it this way or in decimals, it doesn't matter. More realistically, you're probably gonna have like the decimal versions if you do it with your calculator, that's fine. But it's super important that you put the units for this one because it's got units in the problem. So it's asking you for the dimensions and the volume, and then I'll get your question. And then the volume is just gonna be the product of these. 5 over 3, 14 over 3, 35 over 3. So that's apparently 90.74.
Yes.
Okay, so volume is 90.74. What are the units? Inches cubed. So this is what goes in the box. Okay, Netta.
Is it okay if my numbers are out of order, but it's still?
Yeah, it's fine. Okay. This problem happened to be asking you for the dimensions of the box and the volume. Okay. Another problem, right? Whether it's on the homework or the test or whatever, could be asking you for the dimensions of the squares that need to be cut and then the volume. So if I asked you for the dimensions of the squares that need to be cut, what are the dimensions of the squares? It's x by x, right? So what's x here? 5 over 3, right? So if you were asked the dimensions of the squares that are cut, well, the dimensions, it would just be 5 over 3 inches by 5 over 3 inches.
Wait, why is it 5 over 3?
Because that's x. Okay? All right. Okay, so what was the next one? Okay, 9. Yeah, they're fun. Okay. I swear, I wouldn't mind doing these all day. But I do these all day.
You my homework.
If it brings you joy.
No, when I was doing them for the first time in my life, they were, I'm not gonna lie, it would be difficult to get through like even one of them,
Yeah.
right?
But you invented calculus.
No, I did not. No, I did not.
Wait, question on this problem.
Yeah, the
Does
fencing
wire-
problem?
Does the wire go along the riverside or like?
Yeah, let me read it. A rectangular plot of farmland will be bounded by on one side by a river, and on the other 3 sides by a single strand electric fence. Huh?
I did do it.
Yeah. With 800 meters of wire, what is the largest area you can enclose, and what are the dimensions? Okay. Okay, so let's take a look. So this is the river, right? Do you see how like this is the river? And you've basically got your fence here. Okay? So you've got three sides to the fence, and you've got 800 meters of wire. So the 3 sides together are 800 meters. Okay? So these 2 sides are the same, right? So it makes sense to make those x and x. Now, this one, let's call it, give me another variable for that one. Okay, y. So now, all of those together add up to how many meters of fencing? 800. So, and then what is it that I want to maximize in this problem? We want to find the maximum area. We want to find the maximum area. So, yeah. So, since I want to find the maximum area, I need to find an equation for the area. So, that's x times y, right? Is that true? That the area of that fence or that area is x times y? Okay. Now, we can't have 2 variables though, but we know that the perimeter is 800. Well, 2x plus the y is 800, right? Okay, those are x, so how much is y?
Wait.
Okay, let's get-
That's what I was about to say.
Huh?
Wouldn't it be 2x plus 2y?
Well,
Because the Riverside has no fence.
Yeah, but
right,
it's
the
still-
riverside has no fence.
But it's still a part of the.
But you're only
Right, but
counting
you're
the
not
roads
putting a
as
fence-
road.
okay.
Three sides,
Yeah.
not four.
But
Yeah.
the fencing,
Scam.
okay, look, you've got like fencing on like, you know, on like a roll, huh? No.
Why are they using such a complicated?
It's a pentagon.
Look,
It's on purpose.
you take the wire, guys, look, you physically have the wire rolled up on one of those, like, whatever you call them, right? And then so you attach one post here, and now you're unrolling the wire. You go here, 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 and you stop right there.
Wait, okay. But don't you still need to include that side to have the full?
No, because the 800, it's the physical amount of wire
The
you have.
perimeter.
The
But for the
perimeter.
area,
For
you-
the area, yeah. For the area, we don't even care because it's just 1x times 1y.
So what does the wire and electric fence thing have to do with it?
Huh? What is it? Say it again.
What does the wire and the electric fence thing have to do
Okay.
with it?
Because you're asking how much fence, if given this amount of fencing,
Right.
how much space you can enclose if you're only enclosing 3 sides.
If you've got like a set amount of wire, right?
Uh,
There is only a set amount of space you can enclose.
yeah.
So the problem is, how should you do it so you get the maximum area? Because this is one way to do the fence. Another way to do the fencing is like this with the river going here, right? So what should the dimensions be so that you get the maximum area for like your, you know, whatever, yeah.
Well,
Okay.
It's not always the same. You have to get the same.
We have 5 minutes.
Okay, so a of x is x times, what's y? 800 minus 2x. Okay, now, again, derivative, blah, blah, blah. So, what do we do before the derivative? Distribute, correct. Okay, take a derivative. 800 minus 4x. Set it equal to 0. Factor out the 4. So is x 200? Okay? Okay, again, what is this asking you for? Does it want dimensions as well? And what are its dimensions? Yes. Okay, so we want the dimensions. The dimensions, we have the base and the height, right? One side is x, which is 200. The other side is y, which is 800 minus 2 times 200, 400. So the dimensions are 200 meters by 400 meters. And then the area is the product of those. So it's 8 with the 4 zeros. 80,000 meters squared.
Because it's 200 times 4.
200 times 400. Okay? Yeah. It's not.
That took us an hour to do 4 problems.
Yeah, but Yoni, it took us an hour to do 4 problems because I was answering many questions along the way. But really, when we were like this last one, it was just like boom, 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 right? Like, so I'll get you. Okay, so look, 50 whatever. I'll just get you guys started on it. So 53 is you have 2 positive numbers that have a sum of 60. So immediately, what are the numbers?
X, Y, Z.
Right, so one is x, and then the other one is 60 minus x. Yeah?
Yeah.
Okay. What's next?
That's it. That's all.
No. Yeah, but
Perimeter.
what is the maximum product of one number times the square of the other number? one number times the square of the other number. There are two ways you can set this up. One way is you have one number times the, okay, so y equals, times the square, sorry, one number times the square of the other number, correct?
Yeah.
Or you could do it in reverse. One number times the square of the other number. One of these, they're both going to give you the same answer because this is math and math is harmonious. But one of them is exponentially less work. Which one is that?
Second.
The second one, because, right?
Y is square root.
You take out the
Huh?
Y is square root.
And that's what the problem says. It says, what's the maximum product of one number times the square of the other number?
For the second one, you just
What
take
do
out
you
that
do
one
before?
more.
Is this a product rule?
Distribute.
Distribute first. So you get 60x squared minus x cubed. Take a derivative, set it equal to 0, blah, 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 blah. Okay? All right.